A very typical question is because we don't know how to integrate this. That's why they give you some hints. By the result of differentiating this, you can integrate it. So consider x natural log x. By product rule, we differentiate the first one, keep the second one, and then keep the first one, differentiate the second one. That's why we get natural log x plus 1. To have a short conclusion, that means differentiate this will give you natural log x plus 1. In reverse, that means if you integrate the left hand side, by the inverse function, you will get back the original item. But of course, you have plus c here because you don't know the starting point. This is our conclusion. Now we can work on integrate natural log x. We don't know how to integrate this alone, but with a plus 1 at the back, then we can integrate it. So, in order to make good use of the result, I want to plus 1, but without changing value, I need to minus 1 immediately. Same logic as computing square. That's why we have the first two terms, and also we have something that we know how to integrate at the back. It's equal to our left hand side result, x natural log x, and then minus integrate this give us x and c, where c is a constant. Part B is log independence, so natural log x over x dx. They don't give any hints, so most probably you are going to solve it by substitution. There are two factors. One is natural log x and another one is 1 over x. Then you should think about anything you can put inside the differentiation at the back here. 1 over x is an outcome of differentiation. So I try to handle this part. It gives us differentiate natural log x. And this part and the variable are now exactly the same. So you should think it is u du. It's give you u squared and then 1 over 2 plus c. So that's why this will be the whole thing squared divided by 2 and then plus c. Since we already used c in part A already, so we shouldn't use the same label. Let it be c1. Where c1 is a constant, we already finished it. In part C, they say there is a curve, and then we have to express the area bounded by c and the x-axis. So a curve randomly, and then with x-axis. If it is bounded by the curve and x-axis, then of course I will predict there is two x-intercept here. The area should be an integral of each bar, that means the height, that means y, times dx, that means the width. And then we have a limit. The problem is what is the upper bound and lower bound here. As x-intercept point, we know that y equal to 0. Therefore, x minus 1 times natural log x minus 1 equal to 0. By zero product rule, x equal to 1 or natural log x equal to 1. That means x may equal to e. So now I know approximately the curve is like this between 1 and e. 1 is smaller, so it's placed left hand side. And I wonder whether this area is above x-axis or below x-axis. So you may test one single point between 1 and e, maybe you can choose 2. If you choose 2, you will find that this factor, natural log 2, is not big enough to minus 1. So this is a negative factor, while another 2 is positive factor. The whole thing will be negative. So now I confirm the curve is below the x-axis between 1 and e. That's why our answer, the area, is between e and 1, and the result we have to times negative in order to get a positive area. So now our target is to find out this one. And then finally we will multiply negative 1 later on. So this is e1 and then y is x minus 1 natural log x minus 1 over x. It's difficult to handle, so expand it separate to term by term. We have 4x here, and then we separate to 4 different fractions. The first term, I know how to integrate by part A. This one I know. This one I know how to integrate by part B. And the last one, I know it how to integrate also. So write a clear step. Make your hand busy and your brain don't be too rushed. Handle term by term. By part A, this is equal to x natural log x minus x. So we have e natural log e minus e, and then we have to minus 1 natural log 1 plus 1. This part we have e minus e, and then we have minus 0 plus 1. That means 1. Another we have minus xe1, so minus e minus 1. And then that's why we have minus e plus 1, so minus e plus 1 here. We have minus 1 over 2 natural log x whole thing square. So natural log e square minus natural log 1 square. That means 1 square minus 0 square. So we have minus 1 over 2. The last part is just equal to natural log x, e and 1. So natural log e minus natural log 1. That means 1. Therefore, the total is negative e and then positive 2.5, 5 over 2. But of course, you should check is there a positive value. This is a negative value. Just like the consistency with our decision before, the area is below the x-axis. So we make our final decision. The area is equal to negative e1 y dx. So it's negative our finding just now. It is e minus 5 over 2.